over the next couple of lessons we're going to look at inequalities. These little symbols here are our inequalities, and inequalities are a little bit different from an equals. An equals in any equation or sum that we looked at, equals means the same as, so an equals will give us one value of x, for example, if it's x we're trying to find, whereas an inequality suggests a range of values. So if I look at my first inequality here, which looks like a little arrow pointing to the right, this means more than. So if I was to look at this first example here, this means x is more than 2. So this means x can be any value larger than 2. It can be 3, it can be 4, it could be a million. If we're looking at integer values, it could be 2.1, it could be 2.001, any value that is slightly larger than x, however, or slightly larger than 2. However, it cannot be 2 itself. And that is the difference where if I was to look at this inequality here, again an arrow pointing to the right, this means more than or equal to. So if I was to look at this inequality over here, x is more than or equal to minus 3. It can be minus 2, minus 1, it could be 10, 20, a million again, but the difference here is x can in fact be minus 3 itself, okay? So that is the difference between these two inequalities. This just means more than, but this means more than or equal to the value. The little arrows pointing to the left, those inequalities means less than or equal to. Okay, so the same logic applies there. And these symbols here are how we plot them on a number line, which is what we're going to look at doing today, just to start off with a simple exercise with inequalities. Okay, so we are going to show the following inequalities on the given number lines. So our values for x in this first one are x is larger than 2. Okay, so if it's just more than or larger than or greater than, depending what way you're taught it, we are using this symbol here. Okay, so what we do is we find 2 on the number line and we are doing an open dot. So if it's more than or less than but it cannot be equal to it, it's an open dot. So we do an open dot above the 2 with an arrow pointing to the right, indicating that my values of x can be anything larger than 2 in this direction. They can be 3, 4, 5, 6, 7, 8, anything even beyond what's shown on the number line. Okay, so that's all you're doing. So if I want to show x is larger than 2 on this number line, dot above, open dot above the 2 with an arrow going to the right. The next example is to show x is less than minus 1. So again, it's less than, cannot be equal to it. So again, we're using an open dot. This time, however, the arrow is going to go to the left, indicating that the values are less than. So because it's x is less than minus 1, we find minus 1 on the number line, do an open circle with an arrow going to the left this time, indicating that my values of x can be anything less than minus 1. It could be minus 2, it could be minus 3, it could be minus a million, it could be minus 1.1, something really, really close to it, but it cannot be minus 1 itself. That is the difference with the open dot and this type of inequality. The next example, we're looking at x is less than or equal to minus 1. So almost the same as this example, however, it can be equal to this time. So same thing, only this time above minus 1, we're doing a closed dot. However, the arrow still goes to the left. So see, these two examples look almost identical. However, if it cannot be equal to it, it's an open dot. If it can be equal to it, it's a closed dot. So in this example, the value of x does include minus 1 itself, or in anything less than it. Our fourth example here, so we're doing x is more than or equal to minus 3. So again, we find minus 3 on the number line, do a dot above it, and remember, if it can be equal to it, it's a closed dot. Because it's more than, my arrow goes to the right this time. Okay, now I will look at 2 more examples. It is possible to be asked to plot 2 inequalities on the one number line. This kind of tells us what x can't be equal to, a range of values. So if we've been asked to plot x is less than 2 and x is also greater than or equal to 5. So if x is less than 2 but it cannot be equal to it, so we find 2 first off for this inequality, and that is of course an arrow going to the left. Okay, again, just to show that it's less than, open dot. Alright, x is greater than or equal to 5. That's the other inequality I've been asked to show, so that's a closed dot above 5 and the arrow going to the right. So x can be all these values less than 2 except for 2 itself, and x can be all these values greater than 5, and in this case it can include 5 itself. So basically this range of values in the middle is the values that x cannot be for these two inequalities. Okay, you can also be asked, and again our sixth and final example today, this type of question, to show minus 2 is less than or equal to x, which is less than 3. So this basically shows us a range of values for which x can be also. Okay, so this is where you just need to be careful. Okay, so minus 2 is less than x. I mean, if I was to write that another way, you could flip that around. That's also the same as writing x is greater than or equal to minus 2. Okay, so if I was to consider it that way, close that because it can be equal to it, that will be an arrow going to the right. However, I also want to show this, x is less than 3. Open dot for that one, but instead of drawing an arrow pointing that way and an arrow pointing that way, well, you're best just connecting the two arrows to make one straight line. So this shows, this type of inequality, if you ever see it, shows a range of values for which x is between. So x is between minus 2 and 3. It can be equal to minus 2, however, it cannot be equal to 3. So I'll post some examples for you to try, and anything you're unsure about, just ask.